Everybody, we're going to look at 8.2 today. 8.2 is looking at radians and introducing the idea of radians and what they are. Now we're going to start where we're familiar at. We're going to start with degrees. Okay, so this first part asks me to use a protractor. So here's my protractor. Let's make it a half protractor for right now. And it's asked me to use a protractor to graph these angles. So starting out with my first angle here, tells me to start with a 45. So I'm going to start out at 0, oops, 0, and then I'm going to go up to 45 degrees. 45 is about right there. Okay, so there's my answer for number 1. Okay, nothing fancy. And then for my second one, though, I do need to get kind of creative because I need to go out to 210 degrees. But a half protractor is only going to go up to 180. So you either need 2 protractors or what we call a full protractor. Now I do want to, everything we do today, we want to have it to where 0 starts on that right side. So we always want 0 to start over here. And we'll kind of explain why later. And then we're going to go all the way out to 210. So there's going to be my second angle. Now remember, for this angle, it's not the inside here, it's the outside. So this is 210 degrees. Okay, and then I would do the same thing for 300. Okay, let me get rid of that protractor for just right now. So the question is for today, what is radians? Where does it come from? Or what are radians? Where do they come from? And why are they used instead of degrees? Because degrees seem really nice and convenient. Um, and honestly, the best answer for that is because radians are smaller. Um, however, the idea of degrees and the idea of radians comes from the measure of the arc of a circle. Okay, so what I mean by that, say I have a circle. That was not terrible. Um, and I start at 0. So 0 is always going to be out here to the right. Okay, well, you should remember back from like 8th grade math or math 1 that the circumference, the distance around a circle, is 2 pi times r times the radius. And if the radius is 1, then the distance around a circle is 2 pi. So that means halfway then would be pi, and then half of that would be pi over 2, and so on and so forth. So the distance around any circle is 2 pi radians. Now, if my circle is bigger, then obviously that distance is also bigger. But again, it's relative to the default radius. So that's kind of like taking the radius out of the equation and saying that, hey, the distance around as far as the arc goes relative to the radius is going to be 2 pi. So what does that mean? Well, all the way around is 2 pi, which means halfway around is going to be pi. Okay, so if I go only to 180 degrees, I've gone pi radians. Now, if I go half of that, that'd be pi over 2. Make that nicer. And if I went half of that, it'd be pi over 4. And then if I haven't gone anywhere, that would just be 0, right? Okay, so on this first one, we're kind of counting by pi over 4s, because if I go pi over 4, and then go another pi over 4, that's like 2 pi over 4, which is going to simplify down. I go another pi over 4. So we had 2, now we've got 3. Okay, that one's not going to simplify down. This is going to be 4 pi over 4, which will simplify down to that pi. 5 pi over 4, okay, which will not simplify. 6 pi over 4, which does simplify down to 3 pi over 2. And then 7 pi over 4, which also does not simplify down. So again, this is like the distance. Now we could think of these again as in terms of r, right? If I multiply this by r, then it would give me the actual distance that I've gone. But let's not worry about that for right now, because we're going to be looking at what we call the unit circle later. If you're in honors, if you're regular, we're not going to get that to that this year, except maybe way later if we have time. But for right now, we're going to just focus on um, the idea that r is 1. So if I multiply something by 1, it doesn't change anything. Looking at my next one, I've got the same ideas, right? This is still going to be pi out here. And if I go all the way around, I'm going to have 2 pi. And if I haven't gone anywhere, I'm at 0. Well, if I think about this and I look, I've got 1, 2, 3, 4, 5, 6 equal pieces here. Let's go back to the one we did before. I've got 1, 2, 3, 4 equal pieces. So we did it by fourths. So if I've got 6 equal pieces, and it is important that they are equal pieces, then I probably want to count by 6. So 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, and we'll reduce in a second. 5 pi over 6, 6 pi over 6, 7 pi over 6. All I'm doing is counting by pi over 6s. 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, and then 12 pi over 6. Okay, now some of these are going to reduce. The 1 pi is not going to do anything. This one will reduce by 2, though. So I'm going to have pi over 3. This one will reduce by 3, so that's going to give me that pi over 2, which is nice because it matches the one over here on the left. This one's going to reduce by 2, so I'm going to get 2 pi over 3. This one's not. This one's going to reduce to that pi that we want. This one won't. This one down here at 240 is going to reduce by 2. We're going to get 4 pi over 3. By 3, we're going to get 3 pi over 2. By 2 again, 5 pi over 3. And then can't reduce, and then this one turned into that 2 pi that we wanted. Okay, so the nice thing here is that it gives us another way of looking at these. And the nice thing is that it's relative to the radius. That gives us, if we want to talk about distances, a lot faster way of dealing with it than dealing with degrees. Because if I'm talking in degrees, that really doesn't tell me, without bringing sine, cosine, and tangent into it, it doesn't tell me how far I've gone. And that can be somewhat frustrating sometimes, okay? And really the only way to deal about how far I've gone if I'm going around a circle is to talk about radians, okay? So the nice thing about radians is it really tells us how far we've gone around a circle, okay? Um, let's skip over this one for right now. That one's gonna be a little bit easier to look at in a little bit. Okay, so when I talk about angles from a standard position, we always talk about 0 being on the right side, right side. So it's always over here. And then I always go counterclockwise. Okay, that will always happen. Okay, so the initial side and then what we call the terminal side where we end up. Okay, and then that's going to give us our angle. Okay, so for these, again, we're going to need to pull that protractor out. So let's do that. Okay, so for this first one, again, we want to rotate it so it's got 0 in the corner like we want. Okay, so for this first one at 240, I'm simply going to put it here. Oops, down just a little bit. Can't quite get it. It's close enough. And then 240. So out here. Actually went over on both, which makes it actually 240. Okay, and then moving my protractor out of the way. There we go. There's my 240-degree angle. Remembering that it's going like this, right? Okay. Now the question comes into play. What do I do if I want 500 degrees? Because if I look at this, my protractor, even if I use the big one, only has 360 degrees. So if I go around all the way, I hit 360 degrees. So what do I do here? Well, if I'm drawing a circle, circles never start or stop, right? Specifically, they never end. And if one circle has 360 degrees, then what I should be able to do is go 360 degrees and then go some more until I hit 500. Question is, how much more do I need to go to? Well, that's where our calculator comes in handy. I want to go a total of 500 degrees. Clear this. I want to go a total of 500 degrees. I know one full circle is 360 degrees. So I need to go 360 and another 140. Okay, so again, I do want to start at 0, so let's start there. I'm going to go all the way around. I'm going to come back, and then I'm going to go another 140. Okay, so let me get rid of that line. Oops, close enough. Okay, and then we're going to move this out of the way. Now, keep in mind, though, that it didn't just go from here to here. This angle went all the way around and then back. Okay, so that's 500 degrees. Now, the interesting thing is, and we're going to see this later, is that it doesn't matter if we go around that second time. We're going to end up with the same numbers, the same spot. So it doesn't end up really mattering if we go around that second time. Okay, now negatives are a little bit easier. Watch this. So let me clear this. So if going in the positive direction is going counterclockwise, then it would make sense going the other direction should be negative. So this is positive going around counterclockwise, so clockwise would be negative. So that being said, I'm still going to start at 0, and then I'm going to go this way 50 degrees. Now again, my angle is on the inside here. Okay, so positive is going counterclockwise, negative is going the other direction. So what does this mean for us as far as drawing these angles? Okay, so for this first one, 65, we're going to start here, go up to 65, which is about right there. For 300, let's just shrink this just a little bit. Oops, that's too much, you can't see it. No. For 300, we're going to start at 0, and it's the inside here. We're going to start at 0. We're going to come all the way around to 300, which is down here. So then our angle is here. For negative 120, we're going to start at 0. We're going to go the opposite direction, so we're going to go down until we hit 120. So we're going in this direction. And then negative 450, again, we run into that problem of not being on the protractor. So instead of subtracting like we did before, let's add, because we want to try to make it better. Because if I subtracted, right, if I did negative 450 and subtracted 360, well, that just makes my problem worse. Okay, so if it makes it worse, go the other direction. So negative 450 plus 360, and we're going to end up at negative 90. So I'm going to start here. I'm going to technically go all the way around twice and end up here. Okay, so then my angle here looks like this. Okay, so those angles are what we call coterminal angle, where they end up in the same spot. Okay, we're going to look at just this first one here. Okay, so a coterminal angle is, again, is an angle that ends up in the same spot. So if I add 360, I'm always going to end up in the same spot. If I subtract 360, I'm always going to end up in the same spot. And I can do that as many times as I want, and I'm always going to end up in the same spot. So for negative 45 is down here. So if I add 360 to that, I should be at 315. And if I subtracted another 360, let's see where that puts us. It should be negative 405. So if I do negative 45 plus 360, because it's asking for a positive one, that gives me that 315. And if I do negative 45 minus 360, because it asks for another negative one, I get that negative 405. Okay, so a coterminal angle is an angle that's in the exact same spot. Again, the easiest way on coterminal angles is to either add or subtract 360 as many times as we need. Okay, now, probably the most important part of this lesson, how do I go back and forth? Because sometimes it is better to use degrees, sometimes it's better to use radians. Typically, where we talk about graphing, we're going to be using radians. Um, the main reason being is because it makes our graphs smaller. 2 pi is about 6.2, 6.3, whereas 360 degrees, we're looking at a graph that goes from 0 to 360 versus a graph that goes from 0 to about 7, right? And that's a lot nicer to look at. So that's why we use radians specifically for graphing. So to convert between them, if we notice and we go back to what we did before, we found that 1 pi, is equal to 180 degrees, and that was always true, which is all this is saying. It's saying 1 pi is equal to 180. Also, 180 is equal to 1 pi. Okay, now, the problem with doing these is your calculator is going to treat pi as pi. So we need to be careful with how we deal with that pi. When I'm doing this, what's going to happen is I have degrees, um, and I know 180 degrees is equal to pi. But the goal is I want to get rid of these degrees. So if I want to get rid of it, I want to put one on the top, one on the bottom, which means pi is going to end up here. So we're going to multiply what's on top and then divide what's on the bottom. So the problem here is if I put this in the calculator, 120 pi divided by 180 is it's going to give me this really gross decimal answer, but it wants exact measures here. So how do I do that? I'm going to ignore the pi for right now. I'm going to bring it back later. So I'm going to put it over here for right now. And I'm just going to look at the 120 and the 180. Okay, so I put 120 in the calculator divided by 180. Okay, still not a great number. But remember, we can always frac it. So if you hit math and then frac, it'll put it back in a rational form for us. So I've got 2 over 3. Okay, but we can't forget about this pi. Now we're going to bring it back. And since it's in the numerator, we're going to put it back in the numerator. So then my answer here is 2 pi over 3. Okay, now going the other direction is a lot easier. So that one's the more challenging one. Going the other direction is a lot easier. Watch this. So I got negative pi over 12. I want to get rid of pi's, and pi's are equal to 180. This is a lot easier to put in our calculator. So I'm going to do negative pi divided by 12 times 180. So anything on the top we multiply, anything on the bottom we divide, divided by pi. Degrees, okay? So those ones are a lot easier. Going from radians to degrees is a lot nicer, a lot quicker. It's a little more challenging going the other way. So looking at the second one here, I've got 5 pi, or the third one, sorry, over 4. Again, I want to get rid of pi's, 180. Always pi on one side, 180 on the other. Okay, and really you could cancel out those pi's if you want. So I've got 5 pi divided by 4 times 180 divided by pi. 225 degrees. Okay, on this first one here, 135 degrees. I want to get rid of degrees, so degrees is going to go on the bottom. Pi is going to go on the top. So we're going to forget about pi for a second. 135 divided by 180, and then frac it. So I get 3 over 4, and I need to bring that pi back. So 3 pi over 4. Same thing here. I want to get rid of degrees. Take pi out for right now. Okay, the negative's not going to change anything. Just need to put a negative. 180, bracket. So I get negative 2 over 9. Okay, and then bring that pi back. Okay, so on this last one, a lot of times students ask, well, what do I do with that one? Because it doesn't have degrees. Well, remember I said in the last lesson, if you don't put degrees, I'm going to assume you're in radians. And that's what you should assume too. If there's no degrees there, there's no degrees on that one, it's in radians. So remember, radians are pi's. So again, we're going to kind of get rid of this pi here, and then I have 180 degrees. So I'm going to get negative 6.28 times 180 divided by pi. Okay, and I get really close to negative 360 degrees. Okay, which should make sense because 2 pi is about 6.28. Okay, and that's it. So that's how you convert between radians and degrees, and that's the bulk of the lesson that I need you to know and understand, because that's going to be important for what we do later. Again, keeping in mind though where this is coming from, it's coming from those ideas of angles. So remember, for coterminal angles, all you gotta do is add or subtract 360, and you end up in the same spot. Okay, you should be able to do this one now by doing those conversions. So for these ones, right, we would just do pi 180 for all of them. Okay, and again, if you want to cancel those pi's out, that also works. You'll get the same answer. Okay, again, make sure you're coming to RTI time and or before and after school tutoring if you're getting stuck, and I will see you guys next time.